Okay, we're good. Ready? Danielle's laughing at me. Okay. All right, so you should remember this probably a little bit. We talked about this, I think, last year when we were talking about finding angles. Okay. Up until now, we've always been given the angle, and we haven't had to find it. What we've been finding is maybe a missing side. Okay. So for right now, we're going to be looking for an angle. So when finding the measure of an angle, you want to take the inverse trig of the function, or it's also known as the arc. Okay? The inverse is going to be seen as something like tangent to the -1. That's the symbol you'll see that represents the inverse. That's the symbol that's going to say, I want to find an angle measure. Okay? Regular trig, like sine, if I say the sine of something, I'm looking for the comparison of the ratio of your sides, and that allows you to find one of your side lengths. Okay? So, solve for the tangent of x, which is equal to square roots of 3. I want you to find all the values of x where your angle, x represents our angle, falls between 0 and 360, and whose value is square roots of 3 when taking the tangent. So you need to remember that there are always two places where our trig functions are positive and two places where our trig functions are negative. Okay? If I'm asking for the square root of 3 and I want the trig function to be positive, what quadrants does your trig function fall? 1 for all, and third for take. So all students take calculus means tangent is positive here and here. Okay? So what we need to think about then is basically x is going to equal the tangent inverse of root 3. Now these have to be exacts. I don't want you using your calculator. In fact, right now you don't know how to use your calculator. Okay? But I want it to be exact. So you need to remember the tangent of what angle is square roots of 3. This is why you have to know your trig functions forwards and 60. So it's a 60-degree angle here, which means what angle is it here? Well, its reference angle is 60. If the reference angle is 60, it's what do we do in this quadrant? We're going to take it with respect to 180. So it's 60 plus 180, so 240. So x then is equal to a 60-degree angle and a 240-degree angle. And get rid of this equal sign here. I don't want the equal underneath the 360, because otherwise I'm replicating that value, because 0 and 360 are going to have the same. Does that make sense? Okay, try the next one. Find the sine x if it's negative root 3 over 2, and I don't want this equal sign here again. So, draw your little thing. All students take calculus, but I want my sign to be negative. What quadrant do I need to determine that I'm in? Third and fourth. Okay, I don't want it to be positive, so I don't want it in the first and second. That, through elimination, leaves you into the third and fourth. Does that make sense? Stop me if you've got a question. Okay, so the sine of what angle is square roots of 3 over 2? 60 degrees. So we know that x is 60. Put a 60-degree angle in the third quadrant. Put your 60-degree angle in the fourth quadrant. What does that? And so if we were going to write it, we would say x is equal to the sine to the -1 of negative root 3 over 2. So in third and fourth quadrant, what are those angle measures? It's not 60. A 60 degree is right here in the first. A 60 degree here is 120 degrees because we take it away from 180. A 60 degree in the third, we add 180, right? And so that would make it. And then in this quadrant, a 60 degree in this quadrant means we take it away from 360, which leaves me with a 300-degree angle. So this is 180. And I want a 60-degree angle here. I want to go 60 degrees past 180. So 60 plus 180 is 240. In the fourth quadrant, I want a 60-degree angle here. So I'm going to go around 360 and back it up 60 to figure out what this length of my arm is stopping at that point. So remember, it's the angle from 180, the angle plus 180, the angle from 360. Okay? All right, making sense? Okay, next one. Given that side C is 22 and side B is 12, where C is the right angle in a triangle, find the measure of B. So you have to draw these out. I told you C is the right angle. After that, you can put A and B at either corner. It doesn't really matter. I'm going to put A right here and B right here. Okay, this is my right angle. Where is side B? Is it the horizontal, vertical, or diagonal length? Okay, so this is 12, and C is 22, which is the hypotenuse, correct? My question is find angle B. So I'm going to put my little theta mark. That's kind of your standard mark for an angle measure. No, side A is always across from angle A. Side B is always across from angle B. Okay? All right. So I'm going to say, actually I can just say the sine of B is equal to 12 over 22, correct? Would you agree? So I need to see the right, written down correctly. How am I going to solve for B then? B is equal to, what would I write now? What did I write before when I was looking for the angle measures? Sine -1 of 12 22nds. All right, so let's do this on the calculator. Turn your calculator on. And do you see above each of your sine, cosine, and tangent you have -1s? Those are your inverse ones. Those are the ones that find your angle measures. So we're going to do second sine, and then we're going to plug in 12 divided by 22. And we hit enter. And so B is approximately, we'll carry it out, snap, to 2 decimal places. And so B is going to equal approximately 33.06 degrees. An angle. Right now we're only dealing with right triangles. Tomorrow we are not. Yes. You can carry it out to 3, but definitely carry it out to at least 2. Mrs. Rednam will want you to carry it out to 3. So you might just kind of get into the habit maybe of doing 3. Okay, I added here no Pythagorean theorem, so on your notes, please add no Pythagorean theorem also. Okay. I want you using what we're learning. So solve the triangle for all of the missing parts. If B is 20 degrees, or 20, C is 35 in a right triangle where C is the hypotenuse. So would you please draw your right triangle and label all that information? I want to make sure that you can do these right triangles correctly. Well, you can label your angles however you want to. It's just then across from angle A goes your side A. It doesn't have to be. Well, let's do it. Let's see. So I'm saying A, B, C. Right angle, that means this is my 35, and across from angle B, which is little b, is 20. Would you agree? That's how you did it? And you put a right angle at C. because we're going to start tomorrow with not using right triangles anymore. So you've got to indicate where, if you've got a right triangle or if you don't. Okay? All right, so which angle can I find easily? I can really find A or B, really. Doesn't matter, does it? So let's say we do B. What trig function am I going to use for B given these two side lengths? So I'll say the sine of B is equal to 20 over 35. Mathematically, how would I write then if I say B is equal to? To the negative 1 of, which then tells me that B is equal to? Are we in agreement? And it's a degree, so put that little degree symbol there. All right, because we need to know, are we talking about a side length, the angle measure? Well, then this is easy. What does A have to equal? Well, let's do it easily. If this is 90, don't these two have to be 90? Right? If you C is a 90 degrees, then the other two angles have to add up to 90 also. Would you agree? Okay. So then I'm going to say A is equal to 90 minus 34.85, which is about what? 55.15 degree. All right, now I need side A. Side A is missing. It's a little a. So I don't want the Pythagorean theorem. What can I use? Sine of what? So we're using angle A. So the sine of angle A is going to be equal to little a over 35. Would you agree? So 35 sine of 55.15 degree should give you, I got 28.72. Is that what y'all got? Yeah. Are we good? Okay. Next page. All right, evaluate each. Assume that the angles are in quadrant 1. So I'm just leaving you in quadrant 1 right now. All right. If this is telling me, what is, hold on, work from the inside out. What is this giving me? The arc tangent of 6/11. That answer is a what? Is it a side or an angle? The inverse always gives me a what? An angle measure. So this is an angle measure. And if I take the tangent of an angle, I get the ratio of the tangent of any angle. Isn't it opposite over or adjacent? Isn't it a ratio of sides? You've got to look at what you're finding. So if I take the tangent of the inverse tangent, what is that answer going to be? Tangent and inverse tangent, don't they kind of undo each other because they're the same trig function? And one is an inverse of the other, or a reciprocal if you want to think about it. So aren't I just going to be left with 6/11? Right? Aren't they going to cancel each other out? I'm going to get an angle. Well, now I'm going to take the tangent of that angle and get a ratio of sides. Well, guess what? There's the ratio of your sides. Uh-huh. Well, you know two side lengths clearly. Opposite and adjacent. And then if I take the tangent of that angle, I'm going to get back to my ratio of sides. So it's like I go one way to get the angle, then I take the tangent of that angle, and I go back to the ratio of my sides. Okay? Arc cosine. This is the same thing as saying this. It's a shortcut way or another way to say inverse. So the arc means the inverse. So what am I going to get? The cosine of the arc cosine of 2/5. What's that answer going to be? 2/5. Right. Okay. Tangent and arc sine. Are they going to be reciprocals of each other? Or inverses? No, because one's a sine and one is asking for the tangent. Okay, so here's the thing. You determine which angle on a right triangle you want to use. And you work from the inside out. This angle, when I had, so basically this is saying the sine of my angle was 1/3. Would you agree? This is saying this, yes? So if this is my angle, then this means 1 and this means 3, correct? So using the Pythagorean theorem, this is 2 square roots of 2. Square roots of 8, right? 9 minus 1, 2 square roots of 2. You with me? I just did the Pythagorean theorem in my head. So now I'm saying, well, take the tangent of that angle. Well, what's the tangent of that angle? 1 over 2 root 2, which when I rationalize it is root 2 over 4. And remember, I'm wanting this to stay in the first quadrant, so all of these answers are going to be positive. Yeah. Ultimately, if I'm asking for the tangent, I'm wanting a ratio of sides. Do I have a ratio of sides? Absolutely. This gave me my angle. This gives me my side. Okay? All right, here we go. Solve the right triangle given the following. The right angle is J. The legs are JL. So, my right angle is J. My legs are, what am I saying? JK and JL. Sorry. I got cut off over there. Okay. So J is the right angle, indicate it. If K is 40 degrees and little k is 26, find the rest of the information. Okay? Well, that means what is angle L? That's an easy one. Okay? All right, you find the rest. And again, I don't want you using the Pythagorean theorem. And those are the values that I got. Are you okay with those? I use 50 degrees. I said the tangent of 50 is going to equal side L over 26. So 26 tangent of 50 is 30.99. Unless I did something wrong.
No, I got that one, but
Is my math wrong? So cosine of 50 is 26 over J, right? So 26 divided by the cosine of 50 is J? Did I plug it in wrong? Oh, so this is wrong? My math was wrong. What should it be? Okay, so maybe I just plugged into my calculator wrong. All right, you try the last one. Draw your right triangle. You've got to do pictures on these, guys. I defined J to be the right angle. And after that, I don't care where the other letters go. I have it as J is 65 and side L is 55. So that's what I got. Are we good?